So hello everyone, welcome to this video, and in this video I will be explaining the problem count collisions on a road. So this problem was asked in today's weekly contest number 285, and this is a tougher problem, not very easy, but data structure wise we have to solve it. We can solve it by using array only, array or vector. So in this problem you have been given a direction string. I hope you have read this problem well. So you have to tell the number of collision counts. So let's understand the idea of this problem by this whiteboard. So the idea to if we are able to find out that any particular car will collide with the which car, then we can easily calculate the collision score. Okay, so if you pick a particular car moving towards right, then this right car will collide with which car? It will collide with any car that is on its right side. So this is the first condition, and it should be moving towards left or it should be stationary. Similarly, a car moving towards left will collide with any car that is on its left and it is either moving in right direction or it is stationary. So by this logic we can find out that any car will collide with which car, and these both should be the nearest. So if I see this car is moving towards right, it will collide with this car. It is the nearest car that is moving towards left or it is stationary, so I will write 1 here. Similarly, this car will collide with this car. This right car will collide with this stationary car. So this stationary car will not collide with any car because other cars will come and collide with it. Similarly, this left moving car will collide with this stationary car, and this will collide with this stationary car. So if by this logic I can find out that I will see that in the next, when I will iterate this array, I will see that okay, right moving car is going to collide with a car at number index 1. So I will then check that index 1 is a left moving car, so it means that I will increase the count by 2. Suppose here for example, in this case, this right moving car is going to collide with car that is at index 3, and it is a stationary car, so I will increase the count by 1. So this is the whole idea to solve this problem. Now how do I determine this index, this array? To this determine this array, I will make another 2 vectors. One vector will be for right moving car and one will be for left moving car. Okay, so let's name this R and let's name this L. So R will have the collision indexes of all the cars that are moving towards the right direction. So for example, this car is not moving in right direction, so I will just write -1 here. I will write -1 here, -1 here. This car is moving towards in right direction, so I will check that it will collide with which car. So I will just check the neighboring car, that it is a stationary car, so I will write its index here. Similarly, now it is -1, and again this one is -1 here. This car will collide with the car that is next to it, that is the left moving car, so I will write 1 here. Okay, now I will check for left moving cars. For left moving car, I will start from left, so I will see that this is not a left moving car, so I will write -1 here. This is a left moving car, so I will check the left car. It is a right moving car, so I will just write 0 here. For this is not a left moving car, so I will write -1. Again I will write -1, and in this case I will see that okay, this car will collide with which car? It will be this one, so I will write 3 here. And again when I commit this car, so if I see that the car towards in the left of it is not neither a right moving car nor a stationary car, okay, so it means that this is obviously a left moving car. So I will check that this left moving car will collide with which car. So I will get an answer that it will collide with 3, which is already written here. So in case the left car of a left car is not a left car, then I will just copy this 3 here. I hope you are understanding what I say. So now first I will determine these two arrays, then I will just take the max. So the max of these two is 1, the max of these two is 0, the max is 3, the max is -1, the max is 3, the max is 3. So in this way I will determine this array, and that's all we have to do. So now let's code it. So for the coding part, let's begin by increasing the, I think it should be visible. Okay, so let's code. So first I will write, first of all I will just make it dir, because it is very long directions. So int n is equal to dir dot size, direction dot size. Now I will make another variable, int count is equal to 0, which I will return in the end, return count. Okay, also I will write another function here so that I can show you. So these two strings, basically these two arrays, these three arrays I can show you. So I will just write a void function, void print vector int nums for int I is equal to 0, I less than nums dot size I plus plus, see out nums I, and I will write see out end. So I will just be using this function so that I can show you these arrays. So now I will write make some vectors. So vector int left, this vector will contain the collision indexes for all left moving cars. So another vector will be right, RIGHT, and another vector will be collision. So these are my three vectors. Okay, now first I will begin by considering left moving cars. So for calculating the left moving car, this one is the left moving car. Okay, okay, so I will be starting from this one left array. So for left one, the first index that I will fill will be -1. So I will just write left 0 is equal to -1, because if there is a car that is moving towards left and it is the first car, then obviously there will be no car on its left side. Oh, it's a bit confusing. Okay, so I will be explaining this part again. Basically, if there is a car that is suppose this is an array and a car is here that is going towards left. Okay, so in its left there will be no car. Okay, so that's why there will be no car with which this left car can collide. So I will write -1 here. That's why I am writing left 0 is equal to -1. And now I will write this for loop. So for int I is equal to 2, I less than, sorry, I is equal to 1, I less than n, I plus plus. Now I will see that if direction I, if so I'm filling this for left moving car. So if direction I is equal to L, in this case I will now check that the previous car of this left. So if dir I -1 is equal to left, I mean sorry, it is a right moving car, or if it is a dir I -1 is equal to a stationary car. In this case I will write left I is equal to I -1. Else if it is a left moving car, then I will simply write left I is equal to, you can just do a dry run on this code, then you will realize it. So I will write this. Else if else I will just simply write, if it is not a left moving car, it is any other card, then I will simply write it as -1. So this will be my initialization for left moving cars. Now I will go to right, RIGHT, right moving cars. So for that I will just copy it and paste it here, right moving car. Let's copy right. So here right, I will start from the end because of the same logic, because if a car is moving towards say right side, there will be nothing in the left with which it can collide. Okay, so that's why I will write right n-1 is equal to -1, and here I will start from int I is equal to n-2, I greater than equal to 0, I minus minus, and here I will write if a car is a right moving car. First of all, let's convert every left thing into right. So if it is a right moving car and the car that is next to it, just next to it, is either a left moving car or a stationary car, in that case I will write right I is equal to I plus 1, and if not, then I will simply equate it to the this right moving car's collision index. Else I will write -1. So if I just write print function here, so print left, print right, and then print, so I will get this -1 0 -1 -1 3 3. This is for the left one, -1 0 -1 -1 3 3. -1 0, yes, they are similar, and this one is for the right, 1 -1 3 triple -1, 1 -3 1 -1 3 triple -1. So you can see that I have successfully created this left and right. Now I will make the collision vector. So again I will write a for loop for int I is equal to 0, I less than n I plus plus, and see this is simple. So collision I is equal to max of left I comma right I comma right I. Again I will just print this collision, print collision. Let's run this. So you can see 103 -1 3 3, 103 -1 3 3. So my code has been working so far. So I will okay, so now I will calculate the score. So to calculate the score, I will just iterate this for loop. So for int I this thing. Now I will see that if direction I is not equal to s, basically it is a moving car and collision, and it is going to collide with something. So if it is a moving car and it is going to collide, then basically I will write, I'm writing this condition. So if it is a moving car and it is going to collide, now I will check that with which car it is going to collide. So if it is going to so this is my first condition. Okay, if this much satisfies, then only I can increase my this count. Okay, so it is going to collide. Now I will check that this car will collide with which car. So I will write direction collision I. So now I will, so this is going to collide, so either it will be colliding with a moving car or a stationary car. So it is, if it is going to collide with a moving car, then in that case I will increase my count by 2, and if it is not, then I will simply increase my count by 1. After increasing the count, what I will do is that, as it is, as in the question it is written, mentioned that after collision the car that has collided will become stationary. Okay, and the car with which it has collided, basically this car will also become stationary. So that's the problem. Now if we print the direction. So sorry, it's not S but dir. You will see that at the end every car would have become stationary. Okay, something is missing. I should write L here. Okay, so as you can see, every car has become stationary and the total number of collision score is 5. So let me summarize. So basically the first step is to calculate the collision points of all the left moving cars. So I have done that in this part. Then collision points of all the right moving car, then the collision points of all the cars basically in this vector, and then I will calculate the total score. So basically the time complexity is big O of n, 4 times big O of n, so overall it is big O of n, and that's the code for you. So if you like the video, understood the code, so please do subscribe the channel. Thank you and have a nice day. Bye.